Actually going to try and force something to break when we do this one. So we are going to look at hours of TV and hours worked. And I am curious if hours worked predicts the hours of TV that someone watches. Obviously, the thought here is that the more they work, probably the less TV they watch, but we'll find out. So my assumptions, the first couple are pretty straightforward. Both of these are continuous variables. They can take on any value between 0 and realistically a week of information. So they're continuous. I'm not double counting any participants, so it meets independence. And so I'm going to go ahead and start with my outlier check. So I'm going to bring my box plots in for my outliers. And first, let's check amount of TV. And remember, you're going to have to do it twice. So I don't have any outliers in TV. It is kind of interesting that this whisker is so much longer than the other one. But that's kind of an interesting thing for a population. Then I'm going to go back into my chart builder, and I'm going to clear that out. And this time, I'm going to check the hours worked. And you kind of have to scroll a little farther. And let's see if that has outliers. So this one doesn't. So in my write-up, I'm going to have those two statements about my continuous variables and independence. Then remember, I'm going to paste this in, both plots, and I'm going to say there are no outliers. And so I proceeded with my linear regression. Because the other two assumptions have to be checked during the regression. They cannot be checked independently like before. So I'm going to go to regression and linear. I want to know if hours working predicts, if hours of TV predicts, no, hours working predicts hours of TV, sorry. I have to kind of double check myself because I didn't write anything down because I'm a terrible math student. But I checked my model fit. I checked my confidence interval. I'm going to check case-wise. I'm going to check Durbin. I'm going to check descriptives. I'm going to check all the things. Remember, I just did an analysis and it cleared everything out. I have to do it again. It is a little bit annoying. And so I'm also going to have to remember what to move where because I don't remember what goes here. So if I'm looking at this, I'm going to move my Z. Let me get to my images here. I'm going to move my Z RECID to Y. And my Z-pred to X, and I'm going to check my histogram and my normality plots, and then I'm going to click OK. And I'm going to get all kinds of information that I may or may not need. So remember, these three tables are my important tables for my write-up, and then this is important along with this. Now this meets the randomness, so I am getting the homoscedasticity out of this. This is kind of questionable, so I would say this is not a normal, even though the bell curve looks normal. Do you kind of see this extended tail that's happening? It's just a little bit off, and so this would be where, like Dr. Robinson, I'm not 100% sure. Can you put your eyes on it? So I would say that it is going to violate normality, but it's actually okay because we don't necessarily need the residual plots to be normal. We just have to own, hey, these aren't normal. So then I'm going to move into my information in my write-up. So I'm going to, again, all of that information is for someone who's not had this class. I'm going to look at how well hours worked predicts hours of TV watched. That's kind of weird. I always wonder what random people think on the internet when they listen to me talking in these videos because I will make comments to myself. So my degrees of freedom for my ANOVA table are 1 in 47. So I'm going to replace this with 1 in 47. I'm going to replace my actual F value with what's in the ANOVA table of 19.415. Dr. Robinson does not believe in rounding, even though SPSS does. And my p-value here is actually significant. So look at that. We broke an assumption, but we still managed to be significant. So my results are statistically significant. I can answer my research question that hours worked does significantly predict hours watched. And so then I'm going to, in theory, be able to plug in the number of hours watched into my thing. And I should be able to get, hours worked. And I should be able to figure out from that, what are my hours watched? Then for my equation, I'm going to go into this table, and my slope is negative 0.213. And my 17.285 for my coefficient. And then my R squared value would be back up in this table of 0.292. So remember earlier in class, I said you're not typically going to have something like 62%. About 29% of the variance in hours of TV watched is explained by hours worked, which is actually still a large effect. And so that is the walkthrough for regression.